Today I'm going to solve a three-part physics problem about a baseball pitch using kinematic equations. Here's the problem statement. A pitcher throws a baseball at a speed of 83.6 miles per hour from a release height of 1.68 meters. The distance from the pitching mound to home plate is 60.6 feet. Part A. How long does it take for the baseball to reach home plate? Part B. How far does the baseball fall vertically during that time? And Part C. What speed would the pitcher need to throw the ball so that it falls only 1 meter before reaching home plate? First, we want to convert feet to meters. There is 1 foot in 0.3048 meters. We want to take 60.6 feet and multiply that by 0.3048 over 1 foot. The 1 foot cancels out and we multiply 60.6 feet by 0.3048 to get 18.47 meters. Next, we want to convert 83.6 miles per hour to meters per second. We take 83.6 miles per hour times 1,609.34 meters over 3,600 seconds. 1,609.34 divided by 3,600 equals 0.447. We then take 83.6 and multiply it by 0.447. Here we get 37.4 meters per second. Now we have all our conversions and can start writing our known values. Our distance is 18.47 meters. Our VI, or initial velocity, is 37.4 meters per second. And our acceleration here is 0 because there is no horizontal acceleration. Lastly, we don't know the time. Since we are trying to find the time, we are going to use this equation. Plugging in our values, we have 18.47 equals 37.4 t plus 1/2 times 0t to the second. We can simplify this to 18.47 equals 37.4 t plus 0. We will now have 18.47 equals 37.4 t, where we divide 37.4 by both sides. Our final answer is 0.494 seconds for Part A. Next, for Part B, we want to find how far the baseball falls vertically during that time. We have our time found in Part A, and we want to use the same equation. The acceleration is negative 9.8 since it is falling downwards. Now we can simplify to 0.5 times 9.8 times 0.244, which we got from 0.494 multiplied to the second power. This equals negative 1.19, so our final answer for Part B is the ball is falling 1.19 meters downward. Part C. Now we want the ball to fall only 1 meter by the time it reaches home plate. First, we find the time it takes to fall 1 meter using the vertical motion equation. We plug in negative 1.0 meters for delta y, so negative 1.0 equals 0 plus 1/2 times negative 9.8 t to the second. Now we can simplify, so negative 1.0 equals negative 4.9 t to the second power. Here we divide negative 4.9 by both sides. This side cancels out and we get 0.204, which we can then square root to get a final answer of 0.452 seconds. Now we want to find the required speed by using the equation velocity final equals velocity initial plus a times t. There is no acceleration in this problem, so we start with Vf equals Vi times t. Now we plug in our known values, 18.47 meters divided by the time 0.452 seconds to get 40.9 meters per second. This is our final answer, however we can convert it to miles per hour. In 1 meter per second, there is 2.237 miles per hour. So for our final velocity, we can multiply 40.9 by 2.237 to get the final answer of 91.5 miles per hour. Overall, by breaking down the motion into horizontal and vertical components, we can clearly see how the ball's speed, distance, and gravity interact, and how adjusting the horizontal speed changes the ball's vertical drop.